So I just stumbled upon this fascinating implementation of a Merkle tree in Rust, and it's really got me thinking.
Really? Merkle trees. What's particularly interesting about this one?
Well, for starters, it has a fixed depth and is append-only. That means once a leaf is added, it can't be modified.
Wait, seriously. That's a pretty strong guarantee on the data integrity, but isn't it a bit limiting?
True, but consider this. It optimizes for fast Merkle-proof retrieval since intermediate leaves are stored.
Okay, that's unexpected. So what's the trade-off there? Are there performance hits?
Not really. It's designed for quick access to proofs without recalculating everything, which sounds efficient.
That does sound pretty slick, but how does it actually handle larger datasets?
It supports configurable storage backends, so you can choose how to store the leaves like with SLED or SQLite.
Ah, that explains the flexibility, but what about the hashing? What's on the menu?
You can use Kekkak 256 or even Poseidon for hashing. That's quite a range for different use cases.
Poseidon, huh? That's interesting, especially in cryptographic contexts, but is it as secure?
Well, that's a great question. The security of Poseidon is a hot topic. It's designed for efficiency but still needs scrutiny.
Exactly. I wonder how it stacks up in benchmarks against Kekkak 256.
The benchmarks are promising. They measure disk size, throughput, and proof generation times.
Did you see any surprising results there? Any unexpected performance hits?
Actually, yes. The SLED store had the lowest disk size at 290 MB, but memory storage was fastest for proof times.
That's a wild discrepancy. It makes me wonder about the trade-offs between speed and storage efficiency.
Right? And with different stores, you can optimize based on what matters most for your application.
So if I were to use this for a blockchain application, I'd have to think carefully about those choices.
Absolutely, it's like choosing the right tools for a job. The wrong choice could impact your entire system.
Speaking of tools, how easy is it to implement this? Is the interface user-friendly?
It's designed to be simple. Functions like add leaves and proof make it straightforward to use.
That's reassuring, but I wonder if there's enough documentation for newcomers.
Good point. While the README looks comprehensive, it's always a challenge for open source projects.
Right, balancing thorough documentation with feature richness is tough. Did you see any examples?
Yes, there are code snippets showing how to create and customize a tree, which is super helpful.
That's a plus. It seems like a solid starting point for anyone interested in blockchain tech.
Exactly, but I still wonder how it performs under heavy loads. Are there limits?
That's a valid concern. They should conduct stress tests to see where it breaks down.
For sure, and while benchmarks are great, real-world stress might tell a different story.
Totally. I'm curious if anyone has actually implemented it in an active project yet.
That's a good question. It would be interesting to hear feedback from actual use cases.
Right, user experiences could highlight both strengths and weaknesses that benchmarks miss.
And it would also shine a light on how adaptable the implementation is for different scenarios.
Exactly. I feel like real-world applications could really validate or challenge the design choices.
I think we're onto something here. The field of Merkle trees is ripe for exploration.
Absolutely. Plus, with the rise of decentralized apps, its relevance is only going to grow.
So if listeners are looking for a project to dive into, this could be a great choice.
Definitely. It's fascinating how foundational concepts can lead to innovative solutions.
And it makes you realize the importance of thoughtful design in tech. What a journey.
Agreed. Plus, it raises a lot of questions about future developments in cryptography.
Speaking of questions, what do you think will be the next big thing in this space?
I'd say scalable solutions that improve efficiency without sacrificing security will be key.
That's a solid prediction. I can't wait to see how innovations unfold in the coming years.
Me too. With everything evolving so fast, it's hard to keep up but exciting nonetheless.